Today we will continue with the relative motion, and we will deal with plane type questions on the relative motion. What you will see on those cases will be a plane is traveling in still air at a speed, whatever, 210 kilometers per hour, and then the wind is blowing on this direction. Personally, I'm not a big fan of those type of questions because very often you are messing up in which way the wind is going, it's blowing, so I'm not a big fan of those questions, but we will deal with those questions, and we will try to be as much as possible accurate, so no questions are raised when we have a wind that is blowing at a certain direction. So let's suppose that the wind or the speed of the plane in still water, in still air is 910 kilometers per hour. And then we have a wind that is blowing at 52 kilometers per hour at 30 degrees south of east. And now, let's say that the plane is traveling at 20 degrees north of east. What is the resultant velocity that someone that is in the surface of the earth observing this will be? What will an observer see? So in this case, what we have is that the plane is traveling at 910 kilometers per hour at 20 degrees north of east, which means that in northeast southwest axis, we will have a vector that is with a magnitude of 910 kilometers per hour at 20 degrees north of east, and this will be the plane. And when we have the wind, it is south of east, so northeast southwest. We will have a vector that goes between south and east, so this is the velocity of the wind, and it is with a magnitude of 52 kilometers per hour and with an angle of 30 degrees with the east axis. What do we see as the observer in the surface of the earth is the vectorial sum of those two vectors, the velocity of the plane and the velocity of the wind. Since we see even from this configuration here that this is a 2D situation, then when we are operating with vector, the very first thing that we think of is let's use components. Using components means that we will find the horizontal and vertical component of those two vectors and add them together. Horizontal component, vertical component, and then we have the velocity of the plane, and we have the velocity of the wind, and then we have the resultant velocity. So again, as I said the other day, we learn how to operate with vectors for a reason, because we are using them. So now let's create the right angle triangle that includes the given angle. From the tip of the vector, we will draw a perpendicular. And now whatever is along the horizontal will be the horizontal component of the vector of the plane. velocity of the plane, velocity of the plane horizontal, and whatever is along the vertical will be the vertical component. So the vertical component of the plane. And now the horizontal component will be cosine because it's adjacent. So 910 times cosine 20. Make sure that the calculator is on degrees and is positive. So will be 855. It's fine to not even have those decimals, 0.1, but fine. And then for the vertical component, we will use sine. So will be positive 311. Is it 0.2? But we can leave it as 311. And now when we are dealing with the wind, then we will have to create the same process. Create the right angle triangle that includes a given angle. Whatever is on the horizontal will be the horizontal component of the wind velocity, and whatever is on the vertical will be the vertical component of the velocity of the wind. So the horizontal component is positive because it is on the east direction, and will be the same as the cosine, so 52 times cosine 30, and it is positive 45.0, and the vertical component will be negative, and is found by using sine, will be negative 26.0. And now, as we have done on every single vector, when we have been operating with vector, we will add the horizontal components and we will add the vertical components. So 855 plus 45 will be 900, positive 900. And then for the vertical component, 311 minus 26 is equal to positive 285. That means that the horizontal component is positive 900. So positive 900 means that is toward the east axis. And the vertical component is positive 285. 285. That gives us the resultant velocity as closing the rectangle. This will be the resultant velocity, or the velocity that the observer sees as is it standing and observing the motion of the plane. Now, the magnitude of this resultant will be the square root of 900 squared plus 285 squared. So 900 squared plus 285 squared, and the whole thing square root will be the velocity, magnitude of the resultant velocity will be 944 kilometers per hour. But we are not done because we have to find the direction. So angle alpha will be inverse tangent of 285 over 900. And again, make sure that the mode of your calculator is on degrees, because this is the most common mistake, and it is 17.6 degrees. So that means that the observer sees the plane as moving with a velocity of 944 kilometers per hour at 17.6 degrees north of east. Questions? If we add into this question that the object or the plane will move for 2 hours, what is the displacement that this plane is obtaining, then since we are dealing with the uniform motion, then we will go, this will be the resultant velocity times time. And we said that it's 2, let's say, suppose that it's 2 hours, so will be 944 times 2, and 944 times 2 will be 1,888 kilometers at 17.6 degrees north of east. And this will be the total displacement of the plane if everything stays the same for this time given that I said is 2 hours. So we'll see the question in which we are figuring out in what direction the plane should head to if a certain wind is affecting the velocity, but we know in which direction the plane needs to go. So let's suppose that we have this situation. We have a plane that is traveling from Calgary to Edmonton, and we are assuming that Edmonton is straight north of Calgary. And during this time that the plane is traveling from Calgary to Edmonton, it is experiencing a wind that is with a velocity of 12 kilometers per hour at 22 degrees north of west. What is the plane itself can travel with an instill speed of 120 kilometers per hour. What is the direction that plane can have so that will end up in Edmonton? Now, if you had a situation like this and you are the pilot of this plane, and you are saying in your mind that, okay, I will go from Calgary to Edmonton, and then since Edmonton is straight north, this is the assumption that we are doing, then I will head straight north. But by you heading straight north, affected by this wind, then you will not end up in Edmonton, but you will end up somewhere else. So let's draw the situation as u, velocity of the plane, is going up north in Edmonton because you see that Edmonton is straight north from Calgary. And then you have into this, you have a velocity of the wind that is affecting this motion. And this is 12 kilometers per hour at 22 degrees north of west, which means north and west is in this quadrant here, which means, I will draw it with another, that you will have a wind that is affecting your motion like this, which will result into a resultant velocity going this one here. So if this is the velocity of the plane, and you knowing that Calgary is straight south of Edmonton, or Edmonton is straight north of Calgary, you are heading north, the effect of the wind will make you end up not in Edmonton, but in another city. So therefore, you have to adjust the direction of the plane to take into the consideration the velocity of the wind. And how do we do this? We start with, as always, with the relationship that the resultant velocity is the velocity of the plane plus velocity of the wind, as we did on the direction of the boat when we had the river. from here we can say that the direction of the plane, or velocity of the plane, is equal to the resultant velocity minus the velocity of the wind. And in this relationship, we do know what is the magnitude, but we don't know the direction. And we don't know the direction for the resultant velocity, sorry, the magnitude, but we do know the direction. And for the velocity of the wind, we know both the direction and the magnitude. So now we will see and solve this problem. And since this is a 2D situation, what we will do is we will use components. So now in your piece of paper, please go ahead and use components, and I will work here and show it to you. Okay, so now since the relationship that we always start is the resultant velocity is the velocity of the plane plus the velocity of the wind, from here we can find, we can write that the velocity of the plane is equal to the resultant minus the velocity of the wind. And on this relationship, we do know the magnitude of the velocity of the plane. We don't know the direction. This is what we are looking for. We don't know the magnitude of the resultant velocity, but we do know the direction. It's going straight north. And for the wind, we do know both magnitude and direction. But since this is a 2D situation, then what we will do is we will use components. So for the resultant velocity, the components will be horizontal 0 and the vertical component going straight north. Why? Because we have a vector that goes like this, straight up north. So that means that the resultant, the horizontal component of this vector is equal to 0, and the vertical component is whatever is the magnitude of this vector. For the vertical component, we do have a graph or a vector that is between north and west. So we had a vector that is 12 kilometers per hour at 22 degrees north of west. So that means that this angle is 22 degrees, and the horizontal component is negative with the negative that is from the formula, from this relationship here. We will have a positive 11 because it is cosine 12 times cosine 22. And for the vertical component, we will have sine 12 times cosine 22. Yeah. And for the vertical component, we'll have a positive, but since we have the negative sign here, we have to take that into the consideration. So now from the horizontal component, the relationship that we have, or no, the horizontal component of the velocity of the plane is x, is unknown, and the vertical component is y, is unknown as well. So now, from the horizontal component, what we have is that x is equal to 11. It's positive 11. It's positive 11.1. It is positive 11.1. So the vertical component, the horizontal component of the velocity of the plane will be positive 11.1. Now, why am I thinking that this will be the way that the velocity of the plane will be, not on the southeast quadrant? It's because when we are doing the vector diagram, when we are drawing the vector diagram, knowing that the velocity of the plane is the resultant velocity minus the velocity of the wind, the graphical representation will be something like this. So if the resultant is going straight up, and now if we were going to add the velocity of the wind, then will be something like this. because it's north of west. But since we are doing the negative velocity of the wind, will be not this one, but the opposite of it. So this is negative velocity of the wind. And the resultant velocity will be the vector that connects the starting point with the end point. So this angle is 84 point, angle theta is 84.7 degrees. It's safe to say even 85. I'm okay with that. Then you define that the velocity of the plane is 120 kilometers per hour at 84.7 north of east. What that means is that the plane has to head at 84.7 degrees north of east in order to end up north if the wind is 12 kilometers per hour at 22 degrees north of west. From the vertical component, what do we have is that the resultant velocity minus 4.5 is equal to the vertical component of the velocity of the plane. Since we know the direction of the velocity of the plane, we can say that the resultant velocity will be 123.9 or 124. I'm okay with that. Kilometers per hour due north. If the distance between Calgary and Edmonton is 310 kilometers, it's pretty much this is the distance, then the time to go from Calgary to Edmonton on this particular situation will be 310 over 123.9. So 310 divided by 123.9 is 2.5 hours. Question. Okay, so let's deal with a situation where the plane is traveling with a speed of 150 kilometers per hour in still air, and the wind is blowing at 10 kilometers per hour at 30 degrees north of east. Now, what is the direction of the plane going to be if, I will switch the direction from the previous one, if we want the plane to end up let's say east. Okay, so the situation, the vector situation diagram is something like this. This is the resultant vector. Why? Because we want the vector to end up east. Okay, and the wind is 10 kilometers per hour at 30 degrees north of east. Okay, we always start with the resultant velocity is equal to the velocity of the plane plus velocity of the wind. We are looking for the direction of the plane. So the velocity of the plane will be the resultant velocity plus minus velocity of the wind. Is it clear up to here? On this relationship, we do know what is the magnitude of the velocity of the plane. We don't know the direction. And for the resultant velocity, we don't know the magnitude, but we do know the direction is east. And for the wind, we know both the magnitude and the direction. So we can say that this is the horizontal and this is the vertical. Since this is a 2D situation, what we do is we use components. How do we use components on this case? So we'll have horizontal component and vertical component of all the vectors that we are dealing with. The resultant vector, negative the velocity of the wind, and the velocity of the plane. So the horizontal component, since we want the vector to be the resultant component of the velocity, we want it to end up east. The horizontal component will be whatever is the magnitude of the resultant component. And the vertical component of the resultant velocity is equal to 0. Is this clear? Now, for the velocity of the wind, we will construct the right angle triangle, and then this will be the horizontal component, and this will be the vertical component. So the horizontal component will be 10 times cosine 30, and it's 8.66. The negative that the relationship dictates us, plus 8.66. And for the vertical component, we will use the sign. So it will be negative that the relationship dictates us, plus 5.0. Is it clear up to here? Like in everything that we do when we work with vectors, we add the horizontals and we add the verticals. So the horizontal component of the velocity of the plane is unknown. We don't know. And something that we don't know, we assign it with a variable. And the vertical component as well, we do not know. Okay? Now, from the horizontal component, what we have is the resultant velocity minus 8.66 is equal to x, which actually is the horizontal component of the plane velocity. And from the vertical component, what do we have is negative 5 is equal to y, because 1 is 0 here. But what y actually is the vertical component of the velocity of the plane. Is this clear? The question for you will be, with which equation you have to start? You will start with the one that you can solve, the easiest one. And the one that you can solve is the vertical component. So you will use the vertical component now, and you will say that the vertical component of the velocity of the plane is a negative 5 kilometers per hour. Let's see what we have here in terms of the vectors. So we have the resultant velocity that is going east. If we were going to add the velocity of the wind was 10 kilometers per hour, 30 degrees north of east. So will be, if we're going to add it, this will be the velocity of the wind. But actually we want the negative one, okay? So we want the opposite of this vector, negative velocity of the wind. Therefore, the velocity of the plane will be this one here. Understand the vector diagram? So a negative component of the velocity of the plane will give us, so then first of all, the vertical component, if we are considering the angle alpha, will be, I believe that the velocity of the plane was 150. So considering this angle alpha here, the vertical component of the velocity of the plane will be 150 times sine alpha. And now we know that this is equal to 5.0 kilometers per hour. It's negative, and we know that it's negative because that is telling us that the velocity of the plane is between east and south. So from here, we find that angle alpha is the inverse sine of 5 over 150. And in your calculator, inverse sine 5 over 150 will be 1.9 or 2 degrees. So now you can say that the velocity of the plane will be 150 kilometers per hour at 2 degrees south of east. Is this clear? What is that relationship that we have here? Okay. If the question goes further and asks you to figure out what is the resultant velocity, then you will use the relationship that you have from the horizontal component. So the relationship that you had was resultant component, or the resultant velocity minus 8.66 is equal to the horizontal component of the velocity of the plane. And I hope that this is correct. So now the horizontal component of the velocity of the plane is 150 kilometers per hour times, if we take a look here at this diagram that we did, the blue one will be, the blue line will be the horizontal component of the velocity of the plane, which is related to the cosine. So times cosine 2 degrees. Why 2? Because this is what we found. So 150 times cosine 2 degrees is 149.9, which you can say 150, it's fine. But let's keep it 149.9 so that you know what it is, this value. So then from here, the resultant velocity will be 149 plus 8.66, and this will be 158.6 kilometers per hour. And if they're asking you what is the resultant velocity, then you will say it is the resultant velocity is 158.6 kilometers per hour going east. And again, if they're saying that the distance between CTA and CTB is 500 distance between A and B is, let's say, 550 kilometers. How long will it take the plane to go from CTA to CTB? So CTA to CTB will be CTA to CTB will be on the direction that the resultant velocity is. So 550 divided by 158.6. So 550 divided by 158.6, it's 3.47 hours.